Recording is on.
Yeah, I think now it's started.
Okay.
And
Okay then.
so just I will tell a small
Mhm.
introduction what why we are doing this one.
Mm.
So
Okay.
I think Narsim Raji is also joined. So this
Mhm.
is for every 15 days we plan to discuss the technical stuffs, so where people can get the technical knowledge, and the presenter will get like communication and how they can present, so they will get the benefit of that one. So we started, today is the first day. So yeah, you can go ahead. Now the first session, Smita is presenting. So yeah, start, Smita. You can introduce yourself and start.
Yes. Hello everyone. Myself Smita Patil. I completed my MTech in Electronics Telecommunication, and today I am presenting the topic that is CAN, Control Area Network. In automotive field, many protocols are used, that is CAN, Control Area Network, CAN FD, Lean, FlexRay, Bluetooth, Automotive Ethernet. From that, here I am presenting that one protocol, that is CAN, Control Area Network. History of that CAN protocol, that in that this CAN protocol is introduced by the Robert Bosch in 1986. He introduced that, and for the purpose of her introduction or development of the CAN protocol for the automotive applications. Then this protocol is standardized in 1993, and it protocol is used first time in the Mercedes Benz W140.
So
In that CAN
which slide you
protocol,
are in currently? So we are still seeing the first slide, second slide.
history of CAN protocol.
No, I think you need to move a slide.
Then
We are still in this communication protocol used in automotive slide.
one second. Then I
Yeah,
again share.
now it's moving.
But you see the whole screen, or like
I
the
think you can press F5. Otherwise, you there is one option you can put it, this one computer symbol.
uh,
There is
now
here.
it is.
Yeah, now we can see the history slide.
Yeah. So
Okay.
there is a symbol called some small computer in the down. You can press that one. Otherwise, F5. So it will be fit full screen.
Yes, yes, I already press it.
Okay. But yeah, okay.
Now it is okay.
Yeah, I think so. Okay.
Okay. Okay. Then in that CAN standards, that first is the CAN 2.0A and the CAN 2.0B. These are the types of this CAN protocol. This is the history. Then in the introduction part, this CAN stands for the control area network. And why this CAN is introduced, that in automotive, the CAN bus is standard which is designed to allow microcontrollers and other devices to communicate with each other without a host computer. Means here this CAN protocol is used or introduced in communication of microcontroller and other devices without host computer, and it is a message based, that each message carry a message identifier, which is the main point, based on which the priority of the message will be decided. In that CAN frame, the two types are there, that CAN 2.0A and CAN 2.0B. In that 11-bit identifier is in first frame, and type, and 29-bit identifier in second type. This is most important. Then in introduction part, next is there is no need of node identification in the CAN network, which make it very simple to insert or remove a node from the network. Means anytime any node can enter in the communication, that is transmission of the frame, and when error occur, then it can easily remove from the communication, so the remaining communication not affected by that particular node. Then in the CAN network, CAN protocol, that CAN
Smita,
frames.
hello.
Yes, yes.
Still, I think you are sharing screen. Can you share it and stop and share again? Because you are going faster, but we are still see this history screen.
Then now I am on type of the CAN protocol frames.
Yeah. So are you
Are
sharing
you see?
properly? Can you just stop sharing and can you share again? Is it okay?
Okay, okay. Then again, yes.
I think now so many people join. So this is just
Mhm.
information for them. So so we plan to every 15 days once technical seminar where people can get technical knowledge about any technical topics. So it's a free, and if you guys wants to share something, it's also you can prepare some ppt how smita is prepared, so it's possible for you guys, just information. Yes, go ahead.
Now it is okay that I am on type of CAN protocol frames.
Yes, can you move next one?
Okay. Uh, Data frame.
No, I didn't see now. Next frame, next slide.
Then
Still we are in the types of can protocol frame.
then I can share like that. Mm, mm, uh,
Did you
it is
yeah, now data frame. Yeah, now it's going.
you see whole that without any that whole screen.
Yes.
Okay, then it's okay. One second. One second. Uh, yes. Now types of CAN protocol frames. First is the data frame, second is remote frame, error frame, and overload frame. These are the four types are used in the CAN protocol frames. First is the data frame, which is most important, that it can be used to transfer the data, that from one node to another node data can be transferred. This data frame having the seven fields and two main types, can 2.0a and can 2.0b. This data frame, that can 2.0a, is called as a standard can, and this can 2.0b called as a extended can. This standard can having the 11-bit identifier, and this can extended frame having the 29-bit identifier. This first can have the speed 1 Mbps, and second, that extended CAN having the speed 125 kbps. This here is the main frame structure of the CAN protocol. Here I told that it consists of the 7 fields. Here it can be differentiated by the colors. Here 7 colors are there. Then first bit is SOF, that is start of frame. This first. Second is arbitration field. Third is control field. Fourth is data field. Fifth, CRC field. Then acknowledgement field. And last one is the end of the frame. This start of frame, that is starting of the frame, which having the value, that is dominant bit. Here dominant and recessive 2 bits are there. Dominance means value 0 bit and recessive means value 1 bit. This SOF first having the value dominant bit means this uh, node is, or this bus is ready to transfer the frame, ideal. uh, then second is arbitration field. In that, this 11-bit identifier is present. This identifier used to every message having the particular number, that is identifier. In CAN protocol, every node can transfer the message and every node can receive the message. But if 2 or 3 nodes at the same time want to transfer the frame or message, then which node can get first to transfer the that communication bus to transfer the frame, it is depend upon the identifier. This identifier value is less, then that node can first transfer the frame. If the identifier number is large, then this node cannot get the communication bus. Then next is the RTR bit. It stands for remote transmission request. This is used to differentiate between data frame and the remote frame. The remote frame is the another type of the frame. Then here in the data frame, this RTR field having the value 0, that is dominant bit. Then next is the control field. This control field is divided into 3 parts. First is IDE bit, then R, and this DLC. These first 2 bits are reserved for the future purpose, and this DLC is for the data length code. It indicate, or it gives the information about the length of the data, that data can be transferred. Then next is the data field, which is having the 8 bytes. Here in that data field, actual data is present, and which data wants to, that node wants to transfer, which is in that data field. Then next is the CRC field. This is the cyclic redundancy check. This is 15-bit. Here, by using the data field and algorithm, this transmitted node calculate the CRC value, and it transfer toward the receiving node. In the receiving node also calculate by using the algorithm and data one CRC value, and it can compare that transmitted CRC value and received that calculated CRC value. If both are equal, then only the actual or correct data can be transferred from transmitted node to toward the receiver node. Then next field is the control field, acknowledgement field. Here acknowledgement is uh, give, given by the receiving node to the transmitted node. When transmitted node, after receiving the message frame, it can properly, then it can transfer the acknowledgement, that is dominant bit toward the transmitter. When transmitter get that acknowledgement value, that is dominant bit, then he that node can recognize that successfully transmission of or correct transmission of the frame toward the receiving node. Then last is the end of the frame. This end of the frame having the 7 bit, and these values are fixed, that is recessive 7 bits are present in the end of the frame, which indicate that this is the end of that particular message from one node to another node. This is the explanation about that.
And in many interviews, Smita, so
Huh? Huh?
they asked us to write this frame without seeing in many interviews. So
Yes.
yeah, so they asked, can you write can frame format something like this?
Yes, yes, yes. Then we want to then only just draw the 7 fields of that particular frame
Yeah.
and explain that fields.
Yes. Yeah, go ahead.
Yes. This is that one is the 11-bit can protocol frame, and next is the 29-bit. From this two frame here and that frame, here arbitration field in the 11-bit identifier is there, and in here 29-bit protocol, that in arbitration field 29-bit identifier is present. This is the main difference between 11-bit and this 29-bit. Same first start of the frame bit is present, then arbitration field, then control field, data field, crc field, acknowledgement field, and last one is the end of the frame. Here first 11 bits are same, that is like can 2.0a. Difference is here SRR, IDE, and this extended identifier. These three points are extra in the 29-bit CAN protocol. Here, this uh, this SRR means substitute remote request. Then this bit is used to identify that 11-bit frame is transferred, or this 29-bit is bit frame is transferred. Here SRR bit SRR field having the value that is recessive 1. The next is the IDE. This is identifier extension. This also having the value that is recessive 1. Then next is the extended identifier, which is also same used for the message identification. Then next is the RTR bit. Here also having the value 0, because this 29-bit can frame is also for the it is also data frame. So this RTR bit is having the value 0, that is dominant bit. Same here, that control field, these 6 bits are present, but in previous that 11 bit, in that control field IDE bit is there in the control field, but in 29-bit CAN protocol, this R1, R0, and DLC. Same R1 and R0 are for the future purpose, and this DLC, that data length code, which is indicate the length of the next field, that is data field. Here same, that data, which data that node can transfer is present here, that is in the data field. Then same like the 11 bit, here CRC field is there, acknowledgement field is there, and last one is the end of the frame. These two are, this one 11 bit and this 29 bit can frame, that both are for the transmission of the data field. Here data field is here present in that frame. Then from the type of the can frame, first second is the remote frame. This is the remote frame. Remote frame, by sending a remote frame, a destination node can request the data from the source. It can be any node in the network. There are two differences between data frame and remote frame. First is the main difference, that is RTR bit, and RTR bit is equal to 0 at that time. This is the data frame. How receiver can, or any node can identify that it is a data frame or it is a remote frame from this RTR bit. That node can identify it is data frame or remote frame when RTR bit having the value 0, that is dominant bit, that is it is a data frame. And when RTR bit having the value 1, that is recessive bit, means it is a remote frame. And another difference is in data frame, data field is present, but in remote frame this data field is not present, but DLC, that is data length code, uh, field is present. Then in data frame, this indicate the length of the data, but here in the remote frame it indicate the data length of the requested message. And here is that particular remote frame. Here uh, in the data frame, this data field is between control field and CRC field. Here data field is present in the data frame, but in remote frame this control field, after control field directly CRC field is present. Here data field is not present. Then from this protocol frame, third frame is error frame. That is the error frame. Then this error frame having the error flags and error delimiter. There are two types of error frames: active error flag and passive error flag. This is the picture of active error flag. In active error flag, first 6 bits are having the value 0, that is dominant bit, and last 8 bit, which is delimiter, having the value 1, that is recessive. And in passive error flag, this first 6 bit having the value recessive bit, that is 1, and same the delimiter having the value 1. In the error frame, the 2 points are important, that is transmit error counter and receive error counter, TEC and REC. This transmit error counter, which counts the number of transmission error detected on the frames that the ECU sends, and this REC, which counts the number of reception error detected on the frames that the ECU receives. Means this TEC at the transmission time and this REC at the receiver. Uh, this TEC and REC count, how it increase the count, because this count is required to find out the here that error active or error passive. It is required to increase to find out the increase count, that is TEC and REC. But there are another 12 rules are present, that when this TEC increased, when this TEC decreased, same like when REC increase or REC decrease. There are 12 another rules are present. Here, when this REC and TEC having the value less than 128, then error active is present. And when this REC and or TEC value having less greater than 127, at that time this error passive mode is there. And when this TEC having the value greater than 255, then this bus or this node goes to bus of state, means this node um, remove or automatically remove from this bus communication. Here, these are the which type of actual errors present in the CAN protocol. Which errors are present? First is the bit monitoring. Here, in that protocol or that communication, uh, can in that transmitter transmit the bit at the same time. There is a monitoring also done by the transmitter. When transmitter bit is 1 and monitor bit is 1, then it is no any error in the uh, transmission. But if transmitted bit is 1 and received bit is monitored bit is 0, at that time bit monitoring error is occurred. Next is the bit stuffing. When five consecutive bits of the same level have been transmitted by a node, it will add a 6 bit of the opposite level to the outgoing bit stream. Means if five bits are five consecutive bits, means five ones are 11151 recessive bit transmitted. After fifth recessive bit, 0, that is opposite level, that is 0 is inserted. And same, the receiver will remove this extra bit, and it gives the receivers an extra opportunity to detect error. If there are 5 bits and then 0 is present, then receiver remove that 0 and get the original message. And if there is a 6 bits 111 are there, then there is the bit stuffing error. Then next is the frame check. Some part of the CAN message have a fixed format, that is standard defines exactly what level must be occur and when. That is means in that frame, that SOF start of frame, CRC delimiter, ACK delimiter, end of the frame having the fixed value. Uh, they have their fixed value. If rather than that, if receiver occur that that receiver node find out rather than fixed value, then frame check error or frame error can be occurred. Then next is the acknowledgement check. In that, all nodes on the bus that correctly receive a message are expected to send a dominant level in the so-called acknowledgement slot in the message. The transmitter will transmit a recessive level here. If the transmitter cannot detect a dominant level in the acknowledgement slot, an acknowledgement error is signed. Means what? Transmitter transmit the frame, receiver receive it. After receiving particular or a particular frame or calculating CRC, all this frame, if receiver get particular correct frame, after that it can retransmit the acknowledgement bit which is dominant, that is 0. It can, receiver node transmit it toward the transmitter node. And when transmitter node get that uh, acknowledgement bit 0, then it is that there is a no any error. But if transmitter node get value 1 at the acknowledgement bit, then there is the acknowledgement error occur in that message. Then next is the CRC, cyclic redundancy check. Each message feature a 15-bit cyclic redundancy check, that is CRC, and any node that detect a different CRC in the message than what it has calculated itself will signal and CRC error. That I already explained that CRC, that when transmitter node transmit the frame, in that CRC field is there 15 bit. By using the algorithm and data field, that it can calculate the CRC value and transmit toward the receiver bit, receiver node. This receiver node again calculate by using the algorithm and data the CRC value. If both are matches, that transmitted CRC value and calculated CRC value at the receiver node, then no any error. But if not matches, then there is the cyclic redundancy error, that is CRC error occur in that message. The next last frame is the overload frame. If there is any means data frame is transmitted and remote frames are transmitted, but there is, if node received node wants to extra time to transmit the data, analysis the data, or required more time, at that time it can transmit the overload frame, that it indicate that uh, it require the extra time, that require a delay for the next data frame or the remote frame. This overload flag or frame is same as the active error flag. Then last is the interframe space in the CAN protocol. That means IFS frame is used to separate the data frame and the remote frame in that CAN protocol. These are the application of the CAN protocol. That is, CAN is used in the automobiles, aerospace, industrial automation, medical equipment, military equipment, electronics, navigation, etc. The advantages of the CAN protocol, that is CAN protocol having the speed that is 1 Mbps, and when CAN uses the single twisted pair cable for the communication, which minimize the wires between the devices. It reduces the wire, so it save overall cost and time due to the less and simple wiring. Supports auto retransmission of the lost message means if there is any error occur or any message is lost, then automatically in CAN protocol the node retransmit a message again. It works in the various electrical environment without any issue. These protocols support different error detection capabilities such as bit error, acknowledgement error, form error, or and CRC error. The disadvantage of the CAN protocol are that in that CAN protocol, maximum bus length is 40 meter, which restrict the long range application. It support 64 nodes due to electrical loading. In CAN frame, 8 byte of the data can be transferred. If we require more data to transfer, then we can use the, or in automotive, CAN FD can be used. And finally, conclusion: CAN is ideally suited in application requiring a large number of short messages with high reliability. CAN is the message based and not address based. It is especially well suited when data is needed by more than one location and system. Wide data consistency is mandatory. This all about the uh, control area network, that the frames, the data frames, then remote frames, errors which are errors, and the overload frame. Thank you. Then anyone have any question?
If anyone has any question or any doubt, you can ask. Or
Or anyone wants to explain that share any information related to this also, any more information or anything, go ahead.
yep, like for example, like Narsima, I worked some, like if anyone has any experience, they can share uh,
Yes.
on CAN protocol, especially.
Uh, yeah, actually, this is very fantastic. Actually, the and she took over, I think, basic and overview level. That is really very nice. But right now, I'm not the position to explain the things because I came out in the Stockholm. Sorry.
Okay, okay, okay.
Maybe
Yeah,
Okay.
some other day, maybe, yeah. I can add on some points over this.
yeah.
But right now, I think she took a very nice, actually. A
Okay,
nice presentation. Thank you, Smita. Thank you so much.
Thank you.
yeah. So if anyone, if you don't have any questions, so then yeah. So Smita, I okay, you can take a note and we can check together if you want. So can you go to the slide number? Like you have CAN FD and CAN the speed, right? In
Last one, that this one, can
no,
FD,
no,
that
no,
64 byte.
no. Next one, I think speed, CAN speed. So 1 Mbps for the standard and extended is 125 kbps.
This one.
Yeah. So even I am not sure. So we can check. So for CAN 2.0 is 1 Mbps and CAN 2.0B is 125 kbps. So 125 kbps is less small. I mean,
uh,
speed is less.
1 second, I also find that that mistakenly I wrote, or I gonna check.
Yeah. So that we can check also later.
Yes, 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 yes.
And one more important is these frames,
Mhm.
they will check in the interview also, they will ask, can you explain about the different types of frames in CAN, like as you explained, data frame,
Hmm.
remote frame, error frame, overloaded frame. So for me only they asked actually this question, so it's good for you to understand this one and for everyone.
Yes.
And so so as you explained, recessive bit and dominant bit. So
Hmm.
can you do you know this? What is recessive bit and what is dominant bit value?
Yes. Actually, 1 second.
Yeah. So recessive means one, and dominant bit means zero in terms of CAN communication.
That there is a voltage difference, that how this one come and this zero, that zero come, that
Mm, yeah.
uh, if the voltage level is 2.5,
Mm,
and this can low is that in can high and can low are present,
mm,
then can high having the value 2.5 volt and can low having the value 2.45, at that time difference is 0 volt.
Mm.
And for uh, in that I'm now I not having that picture,
Yeah.
that how it works that.
Yes. Yes.
And when can high 2.5 volt and can low 1.5, then difference is 2 volt.
Mm.
That if that means it is the logic 0, that is dominant.
Dominant. Yes.
Means its different is 2 volt,
Mm.
so it is dominant bit 0.
Mm.
And for the logic 1, difference is that 2.5 minus 2.5, that is 1 0, that is for that recessive, they called as a recessive, and this 0 is dominant.
Yes. Yeah. That's good. And do you know one more information? Or there will be one 120 ohm resistor. So I think you are aware of why we use that 120 ohm resistor, right?
To reduce the noise or for the loading purpose.
Yeah, that's correct. So yeah, mm, I think I know only that much. I can refresh it, but maybe I have little more information like these questions and answers so that I can share for you guys.
Yes.
Yeah, thank you, Smita, for the wonderful presentation about the CAN protocol. So we have 15 days to plan for other session. So let's check if anyone can interested to present something. Otherwise, we will send them some technical topics so that we can present for the next week. Yeah,
Okay. Yes.
yeah. Thank you, guys. If you have anything, please ask questions.
Or if anyone wants to share anything, please share.
Yeah, I think I see. If they're not speaking, means silent. Okay, Smita. I think we can wind up. And thank you for
Okay.
once again for a wonderful presentation. So we'll keep continuing. So yeah, thank you.
Thank you everyone for joining. Thank you. Thank you very much.
Yeah, thank you.